Okay, so in this video, we will determine whether this series converges or diverges. As there is a factorial and also an exponential, our good bet here is to use the ratio test. So we're summing the terms of this sequence. Let's call this sequence AN. And as always in the ratio test, we consider now the limit as n tends to infinity of the ratio of an plus 1 over an in absolute value. To obtain an plus 1, we simply replace n by n plus 1 in the expression. So we have n plus 1 to the n plus 1 over negative 2 to the n plus 1 times n plus 1 factorial. As we divide by an, we can instead multiply by the reciprocal. Therefore, negative 2 to the n factorial over n to the n. Well, now let's see if we can simplify this. And as always, we will attempt to do so by pairing up the terms that seem to belong together. So you have a negative 2 to the n plus 1, negative 2 to the n. Subtract the exponents. N plus 1 minus n gives you 1. So we're left with negative 2 on our denominator, but of course in absolute value, this gives us 1/2. Notice that now all the remaining terms are positive, so we can now ignore the absolute value. I will do here two things with each term. I will break this up first as n plus 1 to the n times n plus 1. The power here is 1, so if we multiply the same base, we add the exponents. Check. And I will break down the n plus 1 factorial into n plus 1 times n factorial. If you remember, this is simply the product of the first n plus 1 integers. So n plus 1 times n minus 1 all the way down to 1. But the product of n times n minus 1 all the way down to 1 is simply n factorial. And I will leave these two terms as they are. So times n factorial over n to the n. Well, now we can simplify quite a bit. The n plus 1 over the n plus 1 cancels. The n factorial over itself cancels. And we're left with n plus 1 to the n to the n. Notice that both terms are raised to the nth power. So let's combine them together under a single exponent. This is now our limit. If you think about this as n tends to infinity, well, the numerator tends to infinity, the denominator tends to infinity, and the exponent tends to infinity. So this looks like a non-trivial limit. Let me rewrite it, and hopefully this will look more familiar. Let me divide through here. So n over n is 1, plus 1 over n is 1 over n, all raised to the nth power. And this is not the trivial limit. You can't simply say that as n tends to infinity, 1 over n shrinks to 0, and 1 to n power is simply 1, therefore the limit being 1/2. You have to be careful here. If you look at your case, for this expression, ignoring for now the 1/2, as n tends to infinity, sure, 1 over n shrinks to 0, so you have a 1, but the exponent goes to infinity. This gives you as a case a 1 to the infinity case, which is highly non-trivial. If you remember, previously we have shown that as n tends to infinity, this sequence actually is approaching e. And so the limit in the n is simply e times 1/2, or if you prefer, e over 2. Now recall that e is approximately 2.71828, which is clearly strictly larger than 2. Therefore, e over 2 is strictly larger than 1. So if this limit is strictly larger than 1, the ratio test says that the corresponding series diverges. By, of course, the ratio test. And that's it.